Hello and welcome to another video. We're going to be talking about heteroskedasticity. It's the term that we have worked with and or noticed in the previous videos. And what does it mean? Heteroskedasticity means different variances. Typically, when we have a data in around the trend line or the fit line, the variance is equal in order to around it in order to validate the study. But sometimes the data become extremely scattered, and so the data is going to have a different variances around this, which is going to cause the heteroscedasticity problem. I'm going to go ahead and work with a file that I obtained from this website directly, and www.webbash.edu, and that's an econometrics class, and I'm going to play with it in order to fit my need. So this is basically the file that I downloaded, and I'm going to extract here 5 uh, uh, attributes or 5 fields from it. As you notice here, if I go ahead and hit Control down arrow, it will show me where is the end of that list of rows. Which is going to have, in this case here, we're going to have 6,370. Obviously, maybe not this is the total, but maybe it is the total because I started from not from the top of the, let me go ahead and see, here we go. If I go ahead and say Control Up, it's going to take me all the way to here. So it starts at 5 all the way to 6,000 something. So we will be able to do that in pivot table. I don't know if you have been exposed to pivot table or not, but we will be taking our time in future videos to explain it when we get to the decision-making part of this class, where we're going to be doing some linear programming and also some data extraction. So I'm going to expose you a little bit to it here in order to, first of all, when I don't really get to know the nature of the data, pivot table will help me greatly trying to get myself familiar with it. So let's go ahead and see. This is my selected data that I'm going to be doing the heteroscedasticity test on it. As you notice, I'm going to make it a little bit bigger so I'll be able to see what I'm doing here. The hourly, usually hourly work, the education of that individual, the yearly earning. This is an old data, so it's probably 1999 out from what I looked at, and the race of the individual and their gender. One other thing that I could do basically is to treat the yearly earning as the Y. That's mean the dependent variable education. Usually our work is going to be treated as this is maybe X1, X2, X3, and X4. But one of the best thing is to do here, instead of treating it as a word, let's go ahead and figure that out as a number. So I might associate it the word white is going to be 1. Otherwise, it's going to be, first of all, we have a formula here in this. I just noticed that after I downloaded it, which I'm going to be able to actually turn it into an actual value instead of formula. And this is maybe also is a formula, so I don't need really to mess up with those at this moment, but in a second I'll be able to change it into an actual an actual value, because I want to change the word white for my griddle when I take it to the griddle into whatever value we agreed on it, the number. First of all, in order for me to change that so I don't get into trouble, and I'm glad I need to examine the data if there is any other formula. For example, this here yearly earning or education is coming from another sheet. So in order for me to avoid any sort of trouble or potential trouble, this is what I'm going to do. Either I could go ahead and do that by selecting this, go back and press Control Shift all the way down. That means all the range is being selected. I could copy it, okay, and I could go ahead and click on this one here, and I could go ahead and go to the paste special and paste it as value. So it will be passed as value. Hit escape to take the Martian ant out of it, and look here, I don't have any formula left. So that's actually guaranteed that I'm not going to be with the formula, if you really move things around, because I'm going to change this to from white to whatever the corresponding number for it, I need to be able to really do it as based on value, not based on formula, because if I deleted this columns when I change it into one, then that other one is going to give me an error because the other one will be dependent on this. Now, if it's formula, but now it's not going to be dependent on it because it is constant. So first of all, I want you to know that if I selected this and go with Control Shift down arrow, I'm selecting the whole thing. I wanted to use this as an actual table. For me to change a range of data into a table, I press Control T. Notice here I have also agreed that this table has a header. So I'm going to click OK. Immediately it changes it into a table. Of course, if I don't like the color, I could easily change it. All the table that has to do with it. One thing I could immediately get from the table, I could go ahead and tell me what is the number of the rows associated with that table. 6,366. So many things that you could do with the table you cannot do with the range. First of all, I'm going to go ahead and take that out. Header row should be there. And notice here the header row for the table always stay with us like a freezing pain. And here we go. We're going to go all the way top. Okay. What I'm going to do, because I don't know how many races they listed there, for sure I will be able to tell about the sex, female, and male. That's easy to guess. But here for the race, I don't know what they have classified. So what I'm going to do, I'm going to click anywhere in this table, go to the pivot table, and it's going to be a long video because this is something probably very important for us to know. So we're going to go ahead and say OK. And notice now we ended up with a pivot table. So I'm going to make it a little bit larger. For example, I could go ahead and put the race here. So immediately it's going to give me the total for everybody, which means the 6,366. That's actually a count, not a total. I don't want anything to do with total at this moment. I need a count, which is great. That's what I want. Let's go ahead and say, in this case, I wanted the rate, sex. And we have this many female and we have this many males, and the total is still the same. And if I want to take the sex out and I wanted to get also a race, so here we go. I wanted to see the race, which is the count. I have 4 races. Here we go. Those are the races. And I have 116 of Asian. I have 602 black, and we have 38 Indian, and we have a very large number of 5,610 of white. So this is what we're going to do here is to take this. That's going to help me now to change my table a little bit. And I'm going to copy this one here, go back to the selected data, put that here for now. Okay, I'm going to go ahead and select it. And now I'm going to be able to go ahead and say here or ethnicity or something other than race. Okay, here we go. Let's go ahead and say race 2. Okay, and now immediately we're going to go ahead and do this. I'm going to say here if this one here equal this. Let's go ahead and put that as 1 because so Asian will be 1 in this case. And otherwise, because we have multiple, so we're going to have nested if. We have more than 2, so we have 4 here. If this is equal to this, and I'm sorry, I forgot to lock this, just like I need to lock this, because those are going to be used with for 6,000 some number. So D2, if this D2 equal to black, then we're going to go ahead and do 2. Otherwise, we're going to go ahead and do another if statement. If this is equal to the Indian Eskimo thing, this is going to be 3, since white is the last one in the list. So it will be defaulted to 4 regardless, meaning if the person is not Asian or black or Indian, it's going to be he or she is going to be white. And here we go. Notice here, because we did it in table, it's going to do it for you automatically. And notice also this value is not dependent on this value because even though it was initially dependent, but this is not a formula. This is the formula. Okay, this is the actual formula. And now I could go ahead and select everything here. Okay, and I could go ahead and click in the right button to the right, in the right, while I'm dragging it to the right, go ahead and put it back and let go of my hand and copy as value. So what are we going to go ahead? The operation cannot be completed for one or the following reason. Okay, let's go ahead and not worry about it now because I'll be able to show it to you here. Okay, and do calculated column. No, actually, let's go ahead and do it. The calculated columns, and I'll show you what I need to do with that. So now we're going to go ahead into the sex2, and I'm going to go ahead and say if this one here is equal to female, it's clear, and now it's not in a cell by itself, so I have to enclose it between double quotes. Then that person will be actually associated with digit 1. Otherwise, it's going to be 2 because we only have either male or female. So notice we immediately going to get all those. Okay. Similar to this is a table, so this is part of a table. I could go ahead now and this is a formula. I could go ahead and delete those. I don't need those anymore. See that? And for those here, I'm going to select those and go all the way down by pressing Control Shift P. And I'm going to go to click on this, the right button to the right, and click, drag it to the right, put it back, let go of it, and see if it's going to work. Now it did work with the fact that I copied this as a value instead of a formula. So now I have my data basically as I wanted them to be with the numbers. I'm ready to go ahead and save this, and I'm going to save this, of course, to my test for heteroskedasticity, and let me go ahead and save it. Here we go. Says that I have a file with this name. I'll say override it. Continue by leaving it as XLS. I know because this is an old file, so it's a compatible file. Now I have this one here. I could go ahead and even turn it into an actual instead of table to get it to be ready for me to move. So I'm going to select Control Shift all the way down. So instead of this is table, I'm going to go to the design and convert it into a range, so it will leave me alone. Say, do you want to convert it into a range? I'll say yes, please. Now take away the table. And now I did all the thing by changing it first to table, even looked at the pivot table where I did all the sort of things that pivot table could allow me, which I didn't do really barely nothing. Then I put the data back into constants, so I changed race into an actual number, and now we could go ahead and run our heteroskedasticity. So I'm going to go ahead and go to griddle. So we're going to go ahead and click on griddle here, and griddle, okay, and we're going to go ahead and see if the data is going to be having the same variance, meaning there is no heteroskedasticity, or if the variance are equal to each other, meaning if the significance of B is less than 0.05, that's mean they're homoskedasticity, which means basically they are the variance is the same. If the value that is going to get for the heteroskedasticity is greater than 0.05, it means the variance are not the same and there is an evidence of heteroskedasticity, which is going to be a problem that we have to deal with. All right, which could be the next step that we have to deal with. Anyway, let's go ahead and create that open data. I'm going to go ahead and use user file. I'm going to go to my desktop. Okay, quickly I'm going to, right, here we go. We're going to get it very quickly so I don't have to worry about it. Here we go, data file. I'm going to go ahead and say show me XLS. If I don't see it with XLS, I might have to try XLSX. Here we go. Failed to get workbook information. We need to see what's going on here. Maybe it didn't like all the other data because there's a lot of formula shapes and all that stuff. Yes, that's what it is. So this is what I'm going to do. I'm going to go ahead and get to this data here, select that, go ahead and press Control Shift down arrow, copy it, start a new file, and I'm going to go ahead and select that new file and press Control V. There's a lot of object that Gradle cannot read in that Excel file. So I'm going to make a completely clean, plain file with only my data. If I need anything also in order to understand, I could always go back to the original file. So I'm going to go ahead and save that one more time. And I'm leaving exactly every problem or everything I encounter in order to get you a real sense of what you could go through when you are doing something on your own. So let's go ahead and get that to be saved where it's supposed to be saved. It's in desktop. Here we go. I always have this one here, again. Sorry about going you through a lot of routes here. And data file here. So let's go ahead and say test 4 now with underscore heteroskedasticity. I hope I didn't misspell it, but if I did, it's too late for me to correct it. At least I know what it is. All right, so I could actually go ahead and do the Gradle things here. Now with this file, because I started, it's going to be actually XLSX, because that's a newer, I'm using 2013. So first of all, I'm going to open the data, user, here we go, here we go again, here we go again, here we go, here we go, here we go, here we go, and I'm going to go ahead and look at XLSX, and here it is with my underscore. And now it's not going to give me any problem because I know this file doesn't have any other things but data. So we're going to go ahead and do that. It's going to say you found one variable valid sheet with sheet 1. It bring me all the data. Okay, here, base 262, and here we go. I'm going to leave it as a cross-sectional, which is a cross-sectional. Apply, of course, here the last thing, that's my data in. So if I click in this one here, you could see all the data here for that specific variable. And here we go. This is the education, and this is my yearly income, which is the Y variable, the race, and the sex. Let's go ahead and go to the model and run ordinary least square. And we're going to go ahead and get the yearly earning as the Y, and everything else is going to be basically my independent variable. Okay, which we could make a lot of sense from those beyond the test for heteroskedasticity. We could go ahead and examine a lot of things, but for now I'm just going to show you how we're going to go ahead and test if the data is really have the same variance or if the variance is different. So this is where we're going to go. Here we go. We could take a look at the B values. Some of them are extremely significant, actually all of them. All right. So the next step, and which will everything we have done to get to that point, is to go to the test and click for where we go. Here we go. And heteroskedasticity, and we need to do actually the Y test. Click on it, and here we go. Don't worry about all this data here. The thing that we have to worry here, right there, we're having an issue. That the test for heteroskedasticity is really giving us 0.000. So this is actually less than the 0.05. Then we have to reject the null hypothesis that the variances are equal, which means there is an evidence of heteroskedasticity, which means the variances are not equal in this case. So we have to really deal with this issue. Let me go ahead and run another test to see if we're going to get a different result, even some of the things that we probably had to work with it. I'm going to go ahead and close this, and I'm going to go ahead and close this as well. And let me go ahead and close this one here, and I'm going to also go ahead and open a new data. Data that I have showed you before, the crime, data. I'm going to go ahead, opening a new data will automatically close the current one. I say yes, please. I don't want to save anything, so let's go ahead and do that. This is we have seen in a previous one concerning the total crime. And okay, here we go. And we're going to go ahead and do that. Let's go ahead and do that. And now I could go ahead and run the model as ordinary least square. If I remember, the total crime would be the my, and every other one would be, we go ahead and select all of them by pressing the shift key. And here we go. This is my regression. I could go to the test to check for heteroskedasticity using the White's test. And let's go ahead and see. Aha, this is one is, of course, way larger than 0.05, which means I have to accept the null hypothesis, and the variances are of the same because there is no significance to what we call it, reject the null hypothesis. This is much larger than 0.05. And this is a different flavor of what we did see in the previous example. Thank you for your patience. Absolutely, this is one of the hardest things to do, especially pronouncing the word heteroskedasticity. I mean, it's impossible for me to pronounce it as I should, but at least you know what it is. And one more time, thank you for your time. Bye-bye.